Implementing function overloading and overriding in C++ allows us to write code that is more polymorphic. Overloading is horizontal. It takes place at the same level of inheritance within a class hierarchy. It involves functions with the same name but different types and numbers of parameters. Overriding is vertical. That is, it takes place at different levels within a class inheritance hierarchy and operates within the parent-child relationship. It involves functions with the same name and the same number and type of parameters, but at different levels of inheritance. Today we're going to take a look at overloading versus overriding. And both methods are a means of writing polymorphic code. By polymorphic we mean writing functions that, although they have the same name, they do different things or they take different numbers or types of parameters and arguments. And some of the primary differences between overloading and overriding have to do with their relationship in inheritance or in inheritance hierarchy. First off, overloading is what we call horizontal, meaning that it's at the same level in the inheritance hierarchy. So in other words, we're talking functions or methods that have the same name but accept different arguments inside the same class or inside the same header file outside of a class. Okay, so there's no inheritance involved with overloading, but you do have functions with the same name that take different arguments or different methods. Now overriding, on the other hand, is vertical, and as such it does involve inheritance or the inheritance hierarchy. And that's where you have functions with the same name or methods with the same name, but one is in the base class and the other ones are in the subclasses within that inheritance hierarchy. So the base class might have a function called we'll use the example speak, and then its subclasses might have a function called speak, but it's vertical and they each have their own, or they implement their own special method of speak based on where they are in the inheritance hierarchy. Let's examine C++ function overloading. First let's examine overloading, and so we'll bypass the whole class hierarchy. We have two prototypes here. They're both called speak, so two functions or methods named speak, but the first speak takes no arguments or no methods, and the second speak takes a string argument. Now if it weren't for overloading, this would be a syntax error if we were to compile it. C++ won't let you use two functions or methods with the same name if they are identical. But overloading, since this function takes no arguments and this function takes a string argument, C++ assumes we're just overloading the speak method. And we could do that a dozen times. We could have a dozen different speaks. One might take no arguments, one might take a single string, one might take two strings, three strings, four strings, a string and an integer. Just as long as each one, although it has the same name, would either have a different type or a different number of parameters that it accepts or arguments that it takes. Okay, so if we did that, then in the function definition, just calling speak without any arguments would simply say speaking what a lovely day. Calling speak while we pass in a string argument would call speaking and then use the datastream operator to concatenate whatever string argument was passed in. And you might be asking yourself, what's the usefulness of this? Well, it simplifies your code and makes it more polymorphic so that you don't really have to remember which speak method to call. Again, in other words, we could do this without overloading. We could have speak A, speak B, speak C, speak D, or speak 1, speak 2, speak 3, speak 4, a dozen or more times. But that would make it difficult to remember which speak method we needed in a certain circumstance or situation in code to accept which or ever parameters or arguments we needed to accept. On the other hand, if we overload speak, then we can use it polymorphically, and we can, just almost like magic or like voodoo. We just call speak and we may have a dozen different speak methods, but all we have to remember is speak, and it just magically, calls the right function since it's overloaded based on the arguments that we pass to it, whether we pass no arguments or string or two or an integer, whatever, however many times we've overloaded it. So let's see how that works if we do that. Let's go into main, and here we're just going to call the speak method, and we're going to say A, calling overloaded functions at same level of inheritance, and we'll call speak. And then we're going to call speak the second speak that's overloaded that takes a string argument. Now let's take a look at C++ function overriding. Now let's take a look at overriding. And to do that, we first have to examine inheritance, or our class inheritance hierarchy. So I've just created a simple ADT here. This is our base class. It's got a default constructor and destructor, nothing special there. But it contains a speak method. And the base class says I am an entity, because that's what it is. Now we have several classes that derive from the base class to ADT. These are child objects. And they also implement their speak method. And notice that it's the same. Speak the same number of arguments and the same name. Now, when we're overloading, functions have the same name, but they have to have different arguments, a different number of arguments, or a different type of arguments that we pass in and parameters that we code it to take. When we're overriding, however, that's not the case. They can all be called speak, and they can all take no arguments. Doesn't matter because they're at different levels in the inheritance hierarchy. So this speak says I am an entity, but this speak says I am a dragon, because it's in the dragon class. And this speak says I am a unicorn, and this speak says I'm a flying purple people eater, and this speak says I'm a human. Okay? And the advantage of this is, without getting into virtual methods yet, which we will later, we can enforce structure in our class inheritance hierarchy, such that, let's say that we decided that every child of entity needs to implement its own speak method. Well, we can do this, and later we might even declare that to be virtual or pure virtual. And this way, every single child object has its own speak method that speaks what it is appropriately. So that's how it's set up in our class hierarchy. Now, how would we utilize that? Alright, well, we're going to build 5 objects on the heap. So Alice is a new entity, Jenny's a new human, Bob's a new dragon, Jack's a new unicorn, and Nikki is a new flying purple people eater. If we do that and we build those 5 objects on the heap, if we call the speak methods, because of overriding, even though it's all the same function or method, rather than calling the parent class speak method, each child class is going to call its own speak method, as you'll see. And then down here we're just cleaning up our pointers to the objects that we built on the heap. So if we run this, what would it look like? Well, let's build the project and we'll test it out. And again, I'll modify the background a little bit so you can hopefully see better what's going on. Do black text on a white background. That was my daughter sneezing. And if I go through here, here's A, calling the overloaded functions at the same level of inheritance, and this is horizontal. So again, speaking, what a lovely day, and then speaking, this has been a horrible day. Now we're going to build our objects, and when we build our objects, here we're building an entity, we're building a human, a dragon, a unicorn, a flying purple people eater. So now we're going to call the overridden functions at different levels of inheritance, right? And instead of horizontal, this is vertical. And when we call the speak method, notice it says I'm an entity, a human, a dragon, a unicorn, or a flying purple people eater, respectively. So just illustrating the difference between overloading and overriding, and both are very useful methods for writing code that's more polymorphic.